Okay. So, last class, I think we had not discussed anything. We are just having an introduction class. So, today you will see some videos related to the instruments which you will be using. What is the function of those instruments? Okay. So, I will, before starting, I will tell you some instructions you have to follow strictly. So, as you are from computer science students, computer science branch, so we will expect that all of you will be sincere in the class, you will be attentive in the class, get good marks, and you live. Okay. So, what is the procedure? How will you follow in the lab? Because this is a basic electrical engineering lab is mainly a hands-on lab. Okay, because you are working in offline, so uh, we will be doing this lab in the simulation platform. Prior to that, we have certain procedure you have to follow. First thing is your lab starts at 11. As before 11, you don't have any class. Join 5 minutes before. Okay, all of you are expected to join 5 minutes before the commencement of the lab because your number of students is more than 90. Am I correct or not?
Yes,
Am I
ma'am.
Yes,
correct?
ma'am. Yes, ma'am.
Yes.
Yes, ma'am.
So it will be difficult for us to explain the experiment and do the lab or show the video which you would have done. You would have done for you. We have done the video, so that video will take again 15 to 20 minutes. Okay. Then after that, you will do the simulation in the software simulation software. Okay, so again that will be you will share your screen, so many students are there, then we will be having a discussion and answer discussion round. So many procedures are there, so you are expected to join 5 minutes before because your lab starts at 11 and prior to that you don't have any class. Okay, so within 5 minutes, I will be taking the attendance, and after exactly 11 o'clock, we will start. And in between, I will be calling the names whether you are present or you have left the lab without informing. If you are having certain issues, you tell me that I am facing certain issues. I may be out from the lab. And once I will call anybody's name and you are not present at that time, even if you have given the attendance, you will be marked absent. Okay, after that I will not take it as considered as present. I will, before going to that, I will tell you first the mark distribution, which is important. This is a continuous assessment lab. It's not that at the end of the semester you will perform one experiment and you will write something and you will be evaluated, not like that. This is a continuous assessment. So this lab is of 100 marks. This is of 100 marks. One component is your 40. ସେଇପଟେ କୋଉପଟେ କଲେ ଆପଣ ବାହାରେ ନା HDFC ଜଷ୍ଟ ୱେଟ୍ 1 ସେକେଣ୍ଡ ଆପଣ ବାହାରିବେ ଗେଟ୍ରୁ ବାହାରିଲେ ଆପଣଙ୍କର ଲେଫ୍ଟରେ ଗେଟ୍ରୁ ବାହାରିଲେ ଲେଫ୍ଟ ସାଇଡ୍ରେ ଅଛି ହଁ ଏପଟ ସାଇଡ୍ରେ ଲେଫ୍ଟରେ ଗେଟ୍ରୁ ଆପଣ ଏପଟୁ ଗେଟ୍ରୁ ବାହାରିଲେ ଲେଫ୍ଟ 6390 ଓକେ ସୋ yes.
Ma'am, I actually don't remember that you have told anything about practical copy in the previous
I
class.
will tell
Do
you.
we need
I will tell
anything
you.
right now?
I will tell you.
We
I will
don't
tell
need.
you everything. I will
No,
tell you. My
we
voice
don't
is
need it
audible.
right now. Yes, ma'am.
This one?
In this class, we don't need any, right? Because I don't have any practical copy right now.
No need to. No need to. Don't worry. No need to write.
Okay.
Okay, whatever things I will because I have not told you any instruction. Just wait. Huh? Just wait.
Okay.
So
Okay, ma'am.
just wait. I will tell you everything. Huh? Don't worry for this lab. So this is of 40.
Excuse me, ma'am.
Tell.
Ma'am, actually, I have appointment with dentist, so I'm actually doing the class, right, sitting in front of the dentist. So pardon me for a few moments if I
Okay.
leave the class.
You just text me in the WhatsApp your roll number and whatever
Yes,
problem.
ma'am.
It's me personal, not in the group. Okay,
Okay, ma'am.
personally. Okay.
Okay, ma'am. I'll do.
Huh. So you can leave. So this is 40 marks and this is your 60 marks. 60 marks is your internal. You see, this is your internal. Internal carries more mark than this is your external. Okay, external means at the end semester, after completing all the labs, you will be evaluated out of 40. But 60 marks will be evaluated throughout. This is a continuous assessment. Internal, this will be, we have divided this 60 into different categories. One is your 20 marks is your attendance. Attendance is very, very important. You have to attend. It's not that this is online and you will log in and do something, some other work. You will, okay. So you are not allowed to do that. Don't do that. You are not allowed means don't do that. Okay. So 20 marks is your attendance. Then 20 marks is your daily performance. This is very, very important. How you are performing in the lab. Okay, we can. I know how to take this daily performance. You should be very attentive from whatever the things we are showing the video, whatever things I am discussing in the class. Because before each experiment, I will be discussing the theory. Okay, the theory behind the experiment I will be discussing. Then you will move to the offline lab, which we have done. We have done the video in the offline. We have done it. Technical assistants have done for you. So you will see each and every components, how the connections are done, what are the different apparatus you have used, what is the function of each and every apparatus. Okay, so everything, what are the protective devices you have used, everything you will see in that video, and you should see the video minutely because from there questions will be asked to you how you are doing. Okay, another 20 marks is your report preparation. Okay, this is your report. I will give you the Google Classroom link. There you will, after completion of the experiment, you will write a report. Okay, you will write a report, make it a single PDF, and what are the things you will write, I will tell you, don't worry. So, and that you will upload it in the Google Classroom. For each experiment, you have to upload it. Okay, so this is your 20, 20 and 20. This is your 60. Okay, next is your, this is your 20 component. One is your Viva. This will be your Viva component. At the end, after completing all the experiment, you will be evaluated out of 20. Another 20 is your, another 20 is your quiz test. Okay, this will be a quiz, and after, at the end, you will write a experiment, quiz and experiment. Okay, experiment you will perform and that you will upload it. This is your, am I clear to all of you? Is there any doubt with the marking procedure?
No, ma'am.
Okay, so now come to the now come to the experiment here. I will upload it, this experiment file in the Google Classroom lab. So you will, your experiment are, you can see very clearly, or I have to zoom it again.
No, ma'am. We can see that.
Very good. Okay, okay. So there are, you will do 10 experiments. Okay, the experiments are, I have said here link also, I will be uploading there. Verification of Ohm's law. Ohm's law you have read. Verification of Kirchhoff's current law and Kirchhoff's voltage law. Then third one is understanding electricity. That is, understanding electricity means you should know what are the different types of loads you are connecting in your house, what are the ratings of those loads, how much energy are consumed by those loads. Okay, how energy is calculated in your home, or how what are the different loads you are connecting, and how much energy is consumed by those loads. So those calculations you will be doing, and energy consumption of different home appliances. Just now I have already told you. Make simple DC circuits with cells, lamps, and switches. Okay, Simple DC circuit you will do, okay, with different cells, elements, batteries, loads, lamps, and switches. Okay, you will connect it and see how much current, how much voltage is, what is the potential difference across the lamp, what is the current flowing in the lamp, how much power is consumed in the lamp. So you have to perform simple circuits and you have to work on it. That is your experiment number 3. Experiment number 4 is your verification of superposition theorem. Superposition theorem, you do not know, that I will be teaching you, and you will verify it. This one you will read it in the theory as well as you will do that experiment in the lab also. Okay, theory, when this experiment will be done, at that time I may be completing your theory part also in the class. Okay, then verification of Thevenin's theorem, then study of the RLC series circuit, resistor, inductor, and capacitor series circuit, and understanding the uses of CRT, cathode ray oscilloscope. Okay. Next is to measure the power of three-phase load. 8 number is determination of the voltage transformation ratio of a single phase transformer. This is related to a transformer. Okay. Next is related to Faraday's law, determination of demonstration of Faraday's law. There are 2 laws, first law and second law. You will demonstrate how Faraday's law is applicable. Okay, what is the result of Faraday's law? Then study and use of Megger. Megger is the instrument which is used to measure very high resistance. So you will study how we are using this Megger to measure high resistance material. Okay, or resistance of an insulator. You already know insulator we are using. To what is the function of insulator we are using to protect for safety purpose. Okay, we cannot touch the live conductor, we have to put an insulator. Okay, so this Megger will measure the resistance of the insulator. As you know, your paper, your wood, these are of high insulating material, so you can measure the resistance of those insulators by using this device, Megger, which measures very high resistance, mega ohm resistance. From mega ohm, the name has got Megger. Next, last one is the study of different parts of DC machines. Okay, DC machines, DC generator, DC motor, what are the different parts we are using? So you will study those parts, what is the function of each part, then study of three-phase induction motor. Induction motor, what are the different parts of the induction motor that you will read, and what is the how it is working, how induction motor works, there also you will study. Okay, study means you will know how an induction motor works. Like your fan, in your ceiling fan we are using induction motor. How does the fan operates? Okay, when you are giving the supply, what is happening, what is the principle of operation, according to which principle it is giving you the mechanical energy. Mechanical energy means it is rotating. Similarly, consider a DC machine, that is a DC generator or DC motor. Okay, from motor to a motor, when you are supplying electrical energy, what is happening, how it is working and giving you the rotation or giving you the mechanical energy, that you will read in this experiment. Okay, this is actually study part we have kept. You will not do any experiment. You will study only the different parts, and we have done the video where individual component of the DC machine will be shown to you, and the function of each component will be known to you. Okay, what is the function of each component? What is the name of each machine? Suppose you will see a DC machine. At the outer covering, what you are looking at it, somebody will tell you what you will tell. You will tell the name of that part. Okay, so those different parts will be known to you. So this is all about the experiment. Any doubt with this? This one was I will tell you, no need to bring a physics record or chemistry record or biology record, whatever the record you are following for 12th standard, as you will be continuing this semester online. So you can write in a simply white paper. Okay, then the top of the paper, or make a copy, not paper, sorry, make a copy. Okay, simple white copy will be also work. So you write on the top that experiment, name of the experiment you write, and report you start experiment number 1, name of the experiment. Suppose if this is experiment number 1, you see the aim, what you will write in the report, note it down very carefully. Okay, report carries 20 mark. If you will be deviating from that, you are getting less grade. Okay, so I actually don't want that you get less grade. Okay, so complete the record very carefully, listen carefully how will you write the record. So name of the experiment number you write, aim of the experiment you write, what is the objective, you should know what is the objective of the experiment. Then equipment required or apparatus required, name of the apparatus, what is the range, how much, what is the quantity, how many quantity you are using. Then coming to the theory part very, this should be very precise. Okay, this should be very precise. That means suppose this is verification of Ohm's law, just you write down the statement of the Ohm's law, what is the formula associated with it. This we have done it for you so that you, when you will read, you can understand very carefully. But when you are submitting the report, no need to write everything whatever we have provided to you. You find out the gist of that theory and you write it down. Am I clear to all of you?
Yes.
Am I clear
Yes,
to all of you?
Yes, ma'am. Ma'am, can you repeat what we have to write, ma'am, again?
Okay, so what you will write in the report, suppose you have completed experiment number 1 today. Okay, experiment number 1 today if you have completed, then in the report what you will write down the experiment number 1, aim of the experiment, objective, equipments required. Okay, then theory part, as I have told you, this theory we have provided to you for your knowledge. Okay, but when you are submitting the report, no need to write what the total theory. You have to write down, find out the gist of that theory. That means if it is a verification of Ohm's law. So write down the Ohm's law, write down the formula associated with the Ohm's law. Okay, clear to all of you? Clear to who was
Yes, ma'am.
asking?
Yes,
Okay.
ma'am.
Then this is
Ma'am.
important. Tell.
Ma'am, we will write it in a plain copy.
Plain copy. You write it in a plain copy. No need to purchase that physical record. Sorry, physics record.
Okay.
Okay.
If we have that record, then we can write in it.
Very, very good. If you have purchased the record, then you can write it. No issues.
Okay.
That is not compulsory because that will cost more compared to that. So that's why I am telling you, because you will be completing this semester online. So offline students, they will be maintaining the record. Okay. So this is your offline circuit diagram. You have to draw it. Okay, this is compulsory. The serial which I am telling you, you follow that serial. Offline circuit diagram, you will do it. I am telling to each one of you. I have seen after giving the instruction, I have seen students submitting the record without following instruction. Okay, there you are going to completely, the grade will be reduced. Okay, so be careful. Online circuit diagram, you will do it after completing. You take a snapshot of your whatever you have done. It's not that I have sent it in the manual, you will just copy it. No, whatever the experiment you have done it, because you will be performing the experiment in the online. So you take the snapshot of your circuit diagram and test it. Then no need to write down the procedure. Okay,
Ma'am, we are going to do that experiment on the simulation, no?
Yes, you will do in the simulation platform. The
Okay,
link
ma'am.
will be provided to you. You will do it. Okay.
Yes, ma'am.
After doing, take the snapshot of your simulation. Okay. Procedure is not required. Then observation table. Okay. Observation table, online mode. If you are taking the reading, then online mode reading you will write. Then offline. Online reading, yes, this is online reading because you are doing the experiment in the online, so you will take the reading online. Okay, then this is the procedure of the offline. This is not required. Procedure is not required. Okay, then observation table in the offline mode. Okay, offline mode means the experiment which you will be shown to you, we will be showing that experiment by showing you the video. Okay, there you take the reading. Okay, you will make a comparison in offline and online. Okay, then nature of the graph. Nature of the graph we have shown to you, but what you have to do it is after taking the reading, you have to draw the graph yourself. After getting the reading, whatever you have done the experiment from those readings, you have to draw the graph and you have to paste. You have to submit. After that, conclusion. Okay, conclusion is required. Then discussion question. This is important. Discussion question. Some questions we have kept it for you. You have to find out the answer. Okay, after completing a one experiment, you should be knowing this answer of to this question. After completing one experiment, you should be knowing answer to these questions. If you are not able to answer these questions, that means you are not involved in those experiment. Okay, all the questions answers should be known to you after completion of the experiment. That means you should go depth into the experiment. Okay, you ask a number of questions. Take four technical assistants are there with me. They will be introducing with me. Two faculties, I with me, another madam is there. Six persons are there in your lab. So you ask a number of questions. Okay, whether it is a technical or it is a laboratory or practical based question. Okay, so these questions you should then after that signature, name, roll number, this much you have to make it a single merge in a single PDF. You can do the merge in the online, make it a single PDF, name the report as your roll number and upload it in the Google Classroom. Am I clear to all of you?
Yes, ma'am.
Yes, ma'am.
Tell about the discussion questions one again.
Yes, discussion question C. After completion of the experiment, when you are completing one experiment, your number of questions would come to your mind. Okay, and number of questions will be solved after completing the experiment also. Okay, what is the definition of Ohm's law? You must be knowing the Ohm's law. It's not that your Ohm's law is just statement actually. The statement should be very clear. Okay, it's not that you will tell arbitrarily 2 or 3 statements, not like that. Statement should be very clear. Express Ohm's law in terms of V, I and R. You have to write the relation between V, I and R. State the application of the Ohm's law, where the application Ohm's law is applicable. Okay, so all these things you state whether Ohm's law should be true for both AC and DC circuit. So obviously when you are performing one experiment related to Ohm's law, so you should be knowing whether it is true for AC circuit or it should be true. It is true for DC circuit. That means such involvement in the laboratory should be there. That if such involvement is there, automatically the question will come to your mind. You will ask and you will be able to get the answer. My suggestion is that. Okay, all of you should be involved in the laboratory process. Am I clear to all of you?
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Okay, so this is how you will prepare your report. So the process will be like this. After, tell.
Ma'am, please repeat that image insertion thing, like
Image
circuit diagram.
insertions. Yes, circuit diagram. You are going to do that circuit diagram in the simulation platform. Already, I will be sharing this one, and before the experiment starts, this link will be provided to you. Okay, so here what you will do it is, you will do the circuit. I am showing you, suppose here I will show you how you are exactly your circuit diagram looks like.
Excuse me, ma'am.
Tell.
Ma'am, do we need to write the discussion answers in report?
Yes, answer in the report is there. Discussion, after completing the discussion questions only, you will merge the total PDF and you will submit. Discussion question is compulsory. Am I clear?
Yeah, ma'am.
Or any doubt? Anybody having any doubt? Your report should start from aim of the experiment and it should end after discussion question is complete. Okay, no one should submit the report without discussion question.
Ma'am, before our practical, ma'am, if you are sharing us the link, ma'am, can you write the aim theory, ma'am, whatever thing we have to write before we have come to lab?
That is very good. You have to write. Okay, you have to write this aim of the experiment. Some questions will be asked to you. As I have told you, this is a daily evaluation. Before coming to the lab, you should know what is the aim and objective of the experiment. What experiment you are going to do today. That at least you should know and come to the lab. You should know what is the aim of the experiment, what is the objective. Your questions should come to your mind, why I am doing this experiment, what gain or what output I will get if I am doing the experiment, what benefit it will give it to me. That you should know. What is the objective of the experiment? So I need to say this is your simulation platform where you will be having a number of components here, register, switch. So you will be doing here the experiment in the circuit here. What it was asking. And there, this one you take a screenshot of this experiment. Okay. You will take the screenshot of the experiment and you will submit it in the report. Am I clear? Got it?
Yes, ma'am.
That's the picture in the PDF.
Yes. In the offline circuit diagram is there. Online circuit diagram is there. There you will attach it.
Okay.
Okay. So this is all about the experiment I wanted to tell you. Don't worry. Before next class, you will be doing the first experiment, verification of Ohm's law. Okay. So first 15 minutes, the process will be like this. First 15 minutes, 11 to 11:15 or 20 maximum, I will be discussing the theory. Okay. And after that 15 to 20 minutes, you will be, video will be shown to you, offline video, 15 to 20 minutes. Then after that, you will be given 15 to 20 minutes to perform the lab. After that, sharing of the screen will be start. And within that period, any doubt, any discussion questions, any questions you are having, or I will be asking questions, everything will be done. Or sharing of the screen. Then after that, complete. Yes, tell.
Ma'am, we have to submit for example, means experiment 1, we have to submit on that particular day.
No, I will give some time, not particular day. I will give some time. Okay.
Okay, ma'am.
Yes. So you see,
Attempt all the discussion questions.
yes, you have to write all the discussion questions.
Okay.
Okay. Today, if you are doing the experiment, today is Thursday. So by Wednesday night will be given to you. Within Wednesday night, you will submit. Okay. 7 days will be given to you.
Okay, ma'am.
So this is all about the experiment. Now I want to show you some images, which video will be shown to you. This is,
Ma'am,
these
can
are
you
the
share that manual?
Yes, I will share. Don't worry. Everything I will share.
And ma'am, the discussion questions have to be written in the report itself.
Discussion questions you have to write in the report. Everything you have to write it in the report and submit.
Okay. After that discussion question, ma'am, we have to write our name, roll number.
Yes. Okay. So these are the tell.
Ma'am, I have a question that, ma'am, sir, can you share us some previous examples how the previous year students have done their practical so that we can refer to them at least?
Okay, I will share it. Okay.
Some samples, ma'am.
I will share. So these are the instruments. These are the main instruments which will be shown to you. One is your ammeter. Here you see this is an AC ammeter. You will, I will be telling in the course of the time in the lab. I will tell you what is the difference between AC ammeter and DC ammeter. Okay. This is an AC ammeter which will measure the AC current. You see here there are 3 knobs. 1, 2, 3. This is a common point. Another 2 are these 2 are. I am rotating this cursor. Is it visible, right?
Yes,
ma'am.
Okay.
Yes, ma'am.
Okay. So these are the 2 range. Okay. These are the 2 range. One is, this is written 5 ampere. This is written 2.5 ampere. Here you see, suppose I have connected 1 point here. 1 point is common, is compulsory. Another range you will connect. Out of these 2, any one you will connect. So if you are connecting here, then suppose the cursor, the pointer is at this point. Suppose the pointer is showing at this point. Okay. Then you have to see carefully that which range you have connected. You have connected to 2.5 range. So if the pointer is at this point, you have to take it as 1 ampere. But if you have connected the range to here, if you have connected here to 5 ampere, then you have to take, if the pointer is here, then you have to take 2 ampere. Okay.
Ma'am, can you repeat once?
See, there are 3 knobs. There are 3 knobs. This is a common point where compulsory you will connect it. I will show you the diagram. These two are the 2 ranges. One is your 2.5 ampere range. Another one is your 5 ampere range. 5 ampere range is your higher reading. This is your lower reading. So suppose this pointer has moved. You have connected the ammeter and the pointer has moved to this place where 1 and 2 is written. Okay, 2 is written just above the 1. So if the pointer is in this position, then you have connected the connected to 2.5 ampere range, then if the pointer is at this position, you have to take the lower reading, that is 1 ampere. Okay, and if so, if you have connected to this point, this knob, then if the pointer is same at this position, then you have to take it as upper reading. Upper reading means that you have to take it as 2 ampere. Am I clear? Am
Yes,
I clear
ma'am.
to all of you?
Now, what
Okay.
is
Yes,
the
ma'am.
first
Yes,
one?
ma'am. Yes, ma'am.
First one.
That means there are 2 range. You see here, 1 is written at the above, just above 1, 2 is written. Okay, that means there are 2 range. Here similarly, 3 is it is written as 2, and this is written as 4. Okay, so lower range is there, upper range is there. So while taking the reading from the ammeter, just you have to check properly which range you have connected. Otherwise, the total thing will be wrong. Am I clear to all of you?
Yes, ma'am. Ma'am,
Okay.
that 2.5 ampere, 5 ampere, and ma'am, what is written in red?
Red is common. It is a common point. Okay, this is a common point. That means you need 2 points. One will be coming, current is coming here. Another one is current is entering. Current is going out. So from how much current is coming in a circuit, suppose you have connected an ammeter. It will measure the current in the circuit. Okay, so how will you connect? You have to connect this ammeter between two points. Okay, so 1 point will be connected here, another point either to this range or to this range. Am I clear?
Yes,
Am I
ma'am.
clear?
Yes.
Okay. So this is about the ammeter. This one is the
Ma'am,
DC
there is
ammeter.
another screw, right, in the middle of the ammeter to set the pointer. If it that differs.
Which one?
Ma'am, in the middle, no, ma'am, down, little down, ma'am, below the point. And there is a screw na, to adjust the ma'am pointer if it is default.
Default, it will show you 0. If you have not connected, or if the current is 0,
Yes,
current is not flowing, it will show 0. The
ma'am,
pointer will be
sometimes
0.
without connection, it's default plus or minus sometimes.
Oh,
So,
okay. You are telling by if there is some problem,
ma'am, there
it
is
will
a screw right there in the middle where is B written. Yes, ma'am. That is to
this
adjust
one.
that point. Yes, ma'am.
Okay. This will show you this is automatically there. It is automatically adjusted. It is already adjusted. It will show you 0. If there is no problem, it will be showing
Yes,
0.
ma'am.
Okay.
Yes, ma'am.
So next is this is your DC ammeter, same thing here. Then this is your voltmeter. Okay, same. You are having 2 range, and another one is this one. And next is this is your DC voltmeter. In course of time, I will be telling you what is the difference between DC and AC voltmeter. Okay, today we have some videos, so I will tell you just briefly. You will look at those videos. Okay, this is a wattmeter. Wattmeter always measures the power in watt only. Okay, it measures the power in watt only. That means the watt power is nothing but the power which is consumed in the resistor only or in the resistance only. Okay, that is your I square into R. Whatever the current is flowing in the circuit, multiply current square, multiply with resistance. That is the power consumed by the wattmeter. That is your how much? I square R. This is nothing but your power is the active power. Understood all of you? Or somebody will tell you which power is measured by the what ammeter. sorry, wattmeter, this is your active power or real power is the or the true power. This is the power consumed by a resistance, and according to this power you are paying the electricity bill in your home. In the electricity bill which you are paying in your home, at your home, na, that electricity bill is how much power is consumed by the resistance only. Accordingly you are paying for it. Okay, clear to all of you? That means how much active power you are consuming, how much true power you are consuming, or how much real power you are consuming, accordingly you are paying for it. Am I clear to all of you? Okay.
Yes, ma'am.
So this wattmeter measures only the active power. There are different types of powers you will read in the theory class. So wattmeter measures the active power. One multiplying factor is there. Suppose the wattmeter shows you 5 watt here. Pointer shows 5 watt. We do not take it as 5 watt. We multiply a multiplying factor with that 5 watt, and that gives you the exact reading. Why we are multiplying the multiplying factor, we will discuss. Don't worry now. So this is the instrument. This is called as variac. This is called as variac. Remember this. All these things will be asked to you. This is called as variac. Variac means it is used to vary AC voltage. Variac means variable AC. This is variable. This is AC. Okay, this stands for variable. We cannot use it for DC circuit. Okay, suppose 230 volt is coming to your home, and you are suppose working in a circuit where you require only 50 volt. How will you take it? 230 volt is coming to your home. You are working in a circuit where you require 50 volt. So we can use a variac, and we can give it 50 volt. Am I clear to you? So this is we can rotate this knob. Okay, we will rotate this knob so that, and we can see, we can connect a voltmeter here. We can see how much voltage is, we can change it. Okay, 0 to 230 volt, we can vary it. This is nothing but actually a single phase auto transformer. This is an auto transformer, remember it. This is a single phase auto transformer. One winding is there, and when you are changing the primary from 0 to 230 volt, you are changing, when you are changing this knob, this is actually what we are doing. This is an auto transformer. This is a auto means one single winding transformer. It's not, there are no two windings. Part of winding is common to both primary and secondary. So suppose here you are giving 0 to 230 volt, having a number of turns here in one. When you are changing this knob means what you are doing, you are changing this one, this from this point to this point. So when the N1 number of turn is there, we are getting 230 volt. So when you are moving this one, you are moving this one up and down, then you will get the voltage from 0 to 230 volt according to the number of turns of the N2. Because you are changing, when you are changing this knob, you are changing this point. Am I clear to all of you? Am I clear?
Yes, ma'am.
So when you are
Yes,
changing this knob, when you are rotating this knob or removing this knob means you are decreasing the number of turns of the secondary winding. That is why you are, according to the number of turns of the secondary winding, you will be getting the voltage in the secondary from 0 to 230 volt. Okay? Clear to all of you, or is there any doubt?
Ma'am, can you once again tell about that?
This is a single phase auto transformer. Auto transformer means there is only one winding. Primary is fixed. You will give 230 volt. But when you are rotating, I have shown you the knob. When you are rotating means you are rotating this point. This number of turns you are decreasing, increasing. Am I clear? So that what happens to your N2? N2 will decrease or increase. That means it will maximum, it can give 230 volt when it will be here, and 0 when it will be, there is no number of turns. So 0 to 230 volt, you can get it by using this variac. Am I clear now? Who was asking?
Yes, ma'am.
Okay. So this is a 3-phase variac. Similarly, tell.
Ma'am, if we rotate the knob to 260, so we can
260 it cannot be, na? 260, it cannot be, because max, when you have given a number of turns maximum is my N1, right? So when you have given N1 number of turns is there, 230 volt is maximum voltage. Okay, this is actually a step down auto transformer. You cannot step up. Step up is different. This is a step down auto transformer. Okay, step up will be different, where you will be having number of turns as this one, N1, this is your N1, and N2 will be like this. This one is N2. Here you can get more than 230 volt. Understood? Here N2 will be more. Clear? Here variac is nothing but your step down auto transformer. This is a step down auto transformer. Am I clear to all of you?
Yes. And why auto is used before transformer?
Auto means this is a single winding transformer. Automatically you are doing it. In a two winding transformer, you are having the transformer which you are seeing now. Everywhere you see the transformer near your house, they are two winding transformer. They are not auto transformer. Okay, they are two winding transformer. It's an auto transformer, means only single winding is there. One winding is there, so that's why it is called as auto transformer. Automatically, clear?
Yes, ma'am.
Okay. So this is a rheostat, register. There are 3 points. Okay. Here you see there are 3 knobs. There are 3 knobs. 1, 2, this one is 3. Okay. 2 fixed points are there, 1 variable point. If you are connecting between 2 fixed points, then whatever is the maximum resistance, you will get it. Okay, whatever is the, suppose 100 ohm is the maximum resistance, it will be written here, then you will get the 100 ohm resistance. But if you are connecting one fixed point, another variable point, then if you can get resistance from 0 to 100 ohm. Am I clear to all of you? Am I clear? 2 fixed points if you are connecting, then you are getting a fixed resistance. If you are connecting one fixed and one variable, and you can change the knob and you can vary the resistance. Am I clear now?
Yes,
all of you? Okay, very good. Then this is what is this called? This is called as multimeter. Why it is called as multimeter? Because it can measure multiple things. Multiple things means what? It can measure current, it can measure voltage, it can measure resistance, it can measure AC current, it can measure DC current, it can measure AC voltage, it can measure DC voltage. Okay, there are different knobs here. There you can rotate. Here it is written AC current, DC current, resistance, everything is written here. You will set, what you will do it is, you will just set it in that position and you connect these 2 points across. Suppose you want to measure the resistance, you will connect the 2 points across that resistor. You will set this one in the resistance point. So multimeter will measure the resistance. Okay, so here this one is your, here you will see I have told you, you will, whatever I have discussed, I have shown you in this connection diagram. Here this is an ammeter. I have told you 1 point is coming to the common, this one 5 ampere is going in the bulb. So if you are if you are connected in the 5 ampere range, whatever the reading the ammeter will show you, you have to take the lower reading. Am I clear to all of you?
Yes.
Yes.
All of you understood? If you are connecting 10 ampere, so whatever reading it will give, you have to take the upper reading. Similarly, yes. So this is our it's your DC ammeter. This is your what? This is your DC ammeter. Yes, this is your DC voltmeter. You see here, voltmeter, one straight line at the below V letter, straight line is there. Yes or no? Straight line is there. Got it or not?
Yes, ma'am. Yes, ma'am.
Here, ammeter below A, straight line is there. These are very basic things. It implies that this is a DC. Suppose it is written, then you will know that this is a DC ammeter. Similarly, this is a DC voltmeter. But AC, you will see, this is a DC ammeter voltmeter. Here, both ammeter and voltmeter are connected. Remember that always voltmeter is connected in parallel. Look at here. This one is voltmeter. This is connected in parallel because voltmeter is there to measure the potential difference. So this is connected in parallel. Look at here. positive, this is a common, and this one is connected. That means the load is connected parallel to the voltmeter. Am I clear to all of you?
Yes, ma'am.
Yes, ma'am.
So this is a ammeter voltmeter. Look at here. This is a DC supply. All are DC. Yes, here you see. AC, you see a sinusoidal wave is shown to you. Are the below the letter A? Is it visible or not? Got it?
Yes, ma'am.
Okay. That means this is an AC ammeter. All of you understood or not? This is an AC
Yes,
ammeter.
AC ammeter, yes.
Okay. This is a AC voltmeter. Okay, process is same. You will connection is same. Voltmeter will be connected in parallel. Ammeter will be connected in series. Okay, but the symbol is a sinusoidal symbol will be there. So from there itself you can know that whether it is a ammeter, DC ammeter or AC ammeter. So this is your single phase variac. As I've told you, this one I've already told you. Single phase 230 volt AC supply is there. But with the help of this variac, you can change the voltage according to the number of turns you have provided. So you can, according to your wish, to your circuit, how much voltage you require, you can give it by using this variac. Variac is to vary the AC voltage. Okay. So here, this one is all the connections has been done. Ammeter is connected, voltmeter is connected, wattmeter is connected. Okay. So wattmeter connection, we have done the video. You will see. You will see gradually. Everything I will not tell you today. You will see gradually. This is a three-phase variac. Three-phase variac is.
And like we connect voltmeter, ammeter in the circuit, we can also connect multimeter also in the circuit. Can we?
Multimeter, yes, very good. You
Ma'am,
are
then,
asking
ma'am, then
very
how,
nice question.
ma'am, then how it will work? Cause
No,
ammeter is connected in series and voltmeter in
I
parallel.
am telling you. Suppose I will not connect a voltmeter here. I want to measure this voltage across the load with the help of multimeter. So what I have to do? I have 2 points of the multimeter. I will remove this voltmeter. Okay. What I will do? 1 point I will connect here. Another point I will connect here. I will set, this is a DC voltmeter, DC voltage I want. So I will set the multimeter in the DC volt point. And I will connect those 2 points, simple, those 2 points across the load, and it will measure the DC voltage. Got it? Without the ammeter. Clear?
Yes, ma'am.
In the
Ma'am,
simulation, you will be using the multimeter. Don't worry. Simulation, you will be using the multimeter. Tell me, you are asking some question.
Ma'am, in class 12th, maybe I remember that in voltmeter it has very high resistance, so that it cannot be connected in series. So in case of multimeter, if it is connected in series, then how the current will pass?
See, when you are changing, multimeter has different points, right? Where is my multimeter? Just wait. Multimeter has different position. It's not that you will set it in the current point and you will measure the voltage. You cannot do it. So when you are setting it in the voltmeter point, voltage point, at that time, the resistance is high. It is behaving as high resistance. So it can measure the voltage. Understood? Understood? There are different points. Got it? So when the ammeter is having very less resistance, so when you are setting the point in the current position, then it is having very low resistance. That's why it is measuring the current. Am I clear?
Yes, ma'am.
Yes, ma'am.
Means, ma'am, it means that we cannot measure current and voltage simultaneously, right?
No, simultaneously you cannot measure. Simultaneously you cannot measure anything. In the voltmeter, you can at a time you can measure only. You can simultaneously, if you want to measure, you have to use two multimeter. One you have to connect it for current, another you have to connect it for voltage. These multimeter can measure only one reading at a time, for voltage or current or okay.
Yes, ma'am, got it.
Clear to all of you? So that we will switch over to the video. All of you clear? Or is there any doubt? We will be having clear after we will see the video.
Okay.
Okay?
Yes, ma'am.
Okay. Madam, you can start the video, huh? Okay. So prior to that, I will to just introduce all the many technical assistants are there. They will be introduced. Anjana, madam, are you there? Anjana madam? Okay. Subhasri madam is there. Subhasri Kundu, Dr. Subhasri Kundu madam is there. She is faculty from School of Electrical Engineering, assistant professor. She will be introducing. Madam, you please introduce after the technical.
Yes, madam. Yes. Good afternoon to all of you. I am not taking your theory. Madam is taking your theory. So you people are very much attached with Chitralekha madam, Dr. Chitralekha madam, and definitely we will be interacting in the lab. So your strength is high. So it is difficult for all of you to to remember in one lab. But we will interact and we will do some good medium of contact we will establish during the lab. So what I want to say to you that we both are the faculties and the technical assistants are there, so they will help you to do the lab definitely in different modes. Means we will show you the on offline mode what are the experiments, and also you people will perform the online mode, means in simulation. Okay, but yes, you people will have lot of doubts and that is good, and you will ask to us, you will can interact with us through WhatsApp or in the lab, because lab time is very short, I know. So you people can interact with us in the WhatsApp also. We will have a common group, so there also you people can ask questions. So I just want to give one small introduction of myself, that myself Dr. Shubhasri Kundu. I have completed my PhD degree from NIT Rourkela, and I have joined this college in 2016 January, and till now I am here. And my topic of interest is robotics. So you people, I think you people are in the computer science group, right? You people, your branch is computer science.
Yes, ma'am.
Yes,
Yes.
ma'am.
Yes, ma'am.
So you know that there are a lot of applications in the field of the robotics for the computer science. So if we could interact, if I could be part of your any kind of work, so it will be a great opportunity for me. And if I could help you in any way, so it will be a great work for me also. Okay, so I think your strength is above 90, right? Yes, around.
Yes.
Yes, ma'am.
Yeah, yeah. So we will do the interaction. Okay. Actually, I don't know your names clearly. So as I have missed the introduction class, the first class, so we will interact. So Anjana madam, are you there? I think they will join soon. Yes, Mona Lisa madam is there, right?
Yeah, yes, madam. Yes, madam.
Yes, madam. So can we give us some means views of the lab?
Yes, yes, yes. I'll show.
Yeah, yeah, yeah. Ma'am, you just introduce yourself, and after that, you just go for the lab videos. So they can have a, as they
Yes,
have
yes, yes,
chosen the online, so they will have a look for the real time lab, and they will be they will be enjoying their means real time lab. And after that, we will from the next lab onwards, we will start with the experiment. So we don't have much time for that. So please, madam, start at your end.
yes, ma'am. Thank you, ma'am.
Mm.
Okay, myself, Ms. Punansa Das. I am working as a technical assistant since 2012 here in this department, and I also take BEE lab. Beside that, I am also taking measurement lab, and nowadays I am taking also IoT lab. Then you are in the virtual mode, so we concentrate here because you are not in physical mode. So be attentive here. What we are so to you in the respective lab, and what theory part also to madams are there. And um, mm, uh, thank you to all. Next, Bandana madam, are you here? Actually, madam Anjana madam is in the lab setup. basic electrical lab setup. So she is busy in that. Hello, am I audible?
Yes, ma'am, you are
Yes,
audible,
yes,
ma'am.
ma'am.
Yes.
Yes.
Yes. So in the basic electrical lab, Mrs. Anjana Satpathy is your lab in charge, basic electrical lab in charge. Rest you are in a virtual mode and rest people in the physical mode. So next week our physical mode lab will start. So that's why madam is for setting there. So she is busy in there. So rest except Madam Anjana Madam, um, uh, with me, Bandana Madam is here and Bapin Barar sir is here. Sir, are you here? Barar sir
Yes,
and
ma'am.
Bandana ma'am. Yes, sir. Sir, please give your introduction. After then, I will show the video.
Uh, good afternoon, dear students.
Good afternoon.
Hello.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon to everyone. Myself, Bapin Bodal. I am working as a technical assistant from 2008. Um, and I am involved with different lab, machine lab, electrical machine lab, electrical drives lab, and other labs. I will try my best to clarify your doubts related to our laboratory experiment. Okay, thank you.
Thank you, sir.
Okay, good afternoon,
Bandana
students.
Madam.
Yes, ma'am. I'm just. Good afternoon, students and teachers also present here. Yeah, so I'm Vandana Behel. I'm also working here as a technical assistant since last 5 years, and I have 10 years of experience in this field. Nothing rest you will know after we will keep on taking the classes, then you will know about us more after the means ongoing process of the classes. The most thing is that you are doing computer science engineering, I think so. You are all a computer science engineering.
Yes,
So
ma'am.
you are, this is the basic thing in the first year of your engineering career. You will know about the subject, not only electrical, about electronics. You will have some common subject that everybody should know. Why this had been kept? Because engineer should know everything. Yes or no? खाली कंप्यूटर साइंस पढ़ लेने से या कंप्यूटर्स नॉलेज इज नॉट इनफ फॉर द करियर. सो आपको लाइक घर में क्या बोलेंगे, यू आर एन इंजीनियर, आपको पता होना चाहिए दैट हाउ द लाइट एंड द फैन and the other things, what are the supply you are getting. Most of the student of you may knowing that what is the supply coming at your home, what is the frequency, what are those terms, and most of you may not be. Okay, some of you having the knowledge, some of you not be having the knowledge. So you all are opted for the online mode classes. So we all are here to help you in any manner, like not related to classes only. If you have any doubt regarding means any external doubt, not regarding to the experiment also, you can ask us, we can clear your doubt. We have 2 hours of classes every week. So it may get means we will try to complete the whole process in 2 hours, and your cooperation is required mostly to us, because as in online mode we can't see you student. Already you have completed one semester, yes or no? 6 months you have one semester has been completed.
Yes, ma'am.
How was your experience in
Ma'am, it
online
was
mode?
nice.
It was
No, it
nice.
was
That's
nice.
why you have opted for the online mode again, yes or no?
Yes, ma'am.
So the thing is that everybody, we have very larger strength here. I think so. It's around more than 85. I think so. So we have a more strength here. So it's difficult to cover each and every student as you are present in online. So sometime we will ask someone, and sometime we will in the next class we will ask another one. Randomly we will ask every student, so that everybody should cover. And I request to all of you to be interactive. As it is online mode, we can't see your experiments, facial expression, that whatever we are saying to you, it is getting to you or not. Whatever we are saying, you are listening or not, you are attentive or not. That's the thing. We can't tell you to switch on the camera every time also, because the data problem is there. So it's a request for all of you students that it's a very interesting lab, basic electrical lab, basic knowledge about the electrical engineering. It's a very interesting lab. So all of you be interactive in online mode. That is most important, interaction. Okay, if you will not interact, like some today also ma'am was explaining very well manner, ma'am had explained the instrument thing, and you have interacted, you have asked questions, same manner everybody should ask, should share whatever their views are, whatever they are understanding, whatever they are not understanding. If don't think that I have to complete the experiment, I don't have that much time. अगर आपको today we are not able to complete it because you have so many doubt, that is okay. In the next class we can continue. But the thing is that you need to understand. Everybody need to understand, because we will have 10 experiment, and at the end we will have examination. And if you are not understand each experiment well manner, the examination में जब viva पूछेंगे, then you will not able to tell us. So that's the thing. So I request that, yeah, I think so, I hope so, that you people will be interactive most to ask every doubt and all the things. Yes or no?
Yes, ma'am, definitely.
Yes, ma'am.
Yes, ma'am, definitely.
Yeah, I hope so. And regarding this electrical engineering lab, I'm telling you, it's a very like ma'am had already explained you about the some instrument thing, and most of them you must have seen in the 12th career also, like your voltmeter, ammeter, galvanometer. Actually, you have seen voltmeter, ammeter. Maybe you not. So here specifically, what are the types of meters we are using? What are the uses? Then in the experiment, that practical experiment means आप उसका practical use कहाँ पे देख सकते हो? Like we will make you understand about the transformer. You have seen the transformer. देखे हो कि नहीं?
Yes, ma'am, देखे ma'am.
Yeah, but have you even imagined that what is inside, how it is working? Basic principle though that you have learned in the 12th, in the machine
Ma'am,
chapter in the
theory.
12th. Yeah, basic theory you know about that. But in the practical way, how it is being done, what is its inside, how it's working, how it's the energy is transferring, how it's step up, how it's step down, all the things, the practical things you will get knowledge here. The smaller things. Okay, how the grinder, what are the motor present in the grinder, how the fan is working, how the lamp, what are the switch function, everything. सो आप यहाँ पे हम जब आपको एक्सप्लेन करेंगे, इट इज आप अपना यू यूज टू स्टडी एट योर होम ऑल्सो. आपके अराउंड में एवरीवेयर इट इज इलेक्ट्रिसिटी. ओके, सो कीप एन आई ऑन दैट. If you will have any doubt regarding anything at your home also, you can ask. Okay, so I hope this lab will be very interesting ahead, and in online mode we will keep trying to complete it as in the time, in the stipulated time. So at the last, I want to welcome you all on behalf of KIT University and School of Electrical to the Basic Electrical Engineering Lab. So thank you all. We can proceed for the instrument video. Okay.
Thank you, ma'am.
Okay, thank you.
Thank you, ma'am.
So I am showing you the yes, I am showing you the BAA lab. What is the look like our BAA?
Ma'am, your voice is again.
What's up?
Yes, ma'am.
Yeah,
Ma'am,
it's
network
breaking.
issue,
The
I think.
network issue is there, ma'am.
Yes.
Okay, see the like how our laboratory, as you have opted for the offline, so how our laboratory, from the starting we will take to the, from the entrance of the School of Electrical, we will take to the basic electrical laboratory. You can see from here. Okay, it's a very interesting video. If you will have any doubt, student, in the mid or at the end, you can unmute yourself and you can ask. Okay.
Electrical Engineering. I am Dr. Lipika Nanda, FIC of Basic Electrical Engineering Lab. So this is Block B, the main entrance of our department. So this is our School of Electrical Engineering. We are going towards our Basic Electrical Engineering Lab. Here we have to follow this arrow mark. We have kept some machines, that is slip ring induction motor, synchronous motor, again slip ring induction motor. For the benefit of the students can see what are the different parts available in this type of machines. Basically, these are the AC machines. Before reaching to our Basic Electrical Lab, we are here Electrical Machine Lab. Our each and every lab is well facilitated by the fire extinguishers. Here our students have done good research papers along with the faculties also. So our students are very good researcher. They have published their research in many areas like power system, electrical drive, electrical machines. Now we have reached to our lab, Basic Electrical Engineering Lab. Along with me, Dr. Srikant Alam Sethi sir is there. And also I am having Mr. Pradeep Kumar Sahu sir, Anjana madam and Surya Narayana Mahapatra sir. They are always there in order to assist me in every quarter of the life. Here we are having the fire extinguisher of Basic Electrical Engineering Lab. And here we have displayed the DC shunt motor so that student can see what are the parts available inside the machines. No doubt students will definitely use all these machines practically, but what are the actual parts available inside it, how they look like, how they operate, they can get the idea by looking this experimental setup. So here we are having the safety and precaution what has to be taken if the lab is having fire.
Yes.
Then these rules they
Any
have.
doubt?
Ma'am, we have seen this video previously.
In the last class, you have seen it? Okay.
Yes, yes.
Okay, then we can.
Yes,
Okay,
ma'am.
thank
We
you
have
for
last class
informing.
in it.
Okay, then we can proceed for the instrument video.
Yes, ma'am.
So you have seen the basic electrical laboratory, huh?
Yes, ma'am.
Yes, ma'am.
So your near and friends will do physical lab here, and you can do for the simulation. So for simulation, you should have much knowledge about the various instrument. So we can proceed. Ma'am had already given the brief introduction about the ammeter, voltmeter, and wattmeter. So and variac. So we will show the video for that one.
Dear students, today we will discuss how to measure current of an electrical load. Generally, electrical loads like fluorescent tube, motor, lamp, refrigerator, television. Today we will choose a lamp load as an electrical load. This is a tungsten filament lamp. This filament is made up of tungsten material, and its rating is 200 watt and 230 volt. It has two terminals, terminal 1 and terminal 2. Now we connect this bulb to a holder, and just this is my DC supply. In the DC supply, this is my positive terminal or live positive terminal, and this is my neutral or negative terminal. Now just we connect the circuit. and on. Then bulb is glowing. In that circuit, we have to measure how much current will flow that circuit. How to choose an ammeter? Now our formula is I equal to P by V. P means power, V means voltage. In that filament lamp, our wattage is 200 watt and 230 volt. That's why I equal to P by V, means our current, maximum current flow this load is 0.86 ampere. Means maximum current is flow through that circuit is 0.86 ampere. That's why we choose 0 to 1 ampere ammeter. Just we connect that, and in that circuit, this is my positive terminal and this is my negative terminal. Positive, and this is my ammeter common, and this is my 1 ampere. And this positive terminal goes to the common point of the ammeter, and then range of the ammeter goes to bulb, and bulb return point is goes to the negative point. So that we connect the circuit. Now the circuit is already connected. Means this is my positive and this is my, and from 1 ampere to lamp, and lamp other end goes to the negative. This circuit is already completed. Now we give the supply. Bulb lamp is glowing. Now lamp is glowing, and our current is maximum flowing through that circuit is 0.55.
Ma'am, the video is finished.
Ma'am, video is gone.
Finished.
Any doubts, student, regarding
No,
this? Ma'am
No,
had
ma'am.
already told about the different range and how to take only the connection here, how the emitter is being connected. It is connected in series, but here only the connection. Regarding the connection, it has been explained.
Excuse me, ma'am.
Yes.
Ma'am, here in the formula I is equal to power by voltage. We have taken the voltage to 230 volt, but here the DC supply is 220. Why we have taken 230 volt?
DC supply is 220. Why we have taken 230?
Yes, ma'am.
It's just maximum like P by VI you have telling, na?
Yes, ma'am. Yes, ma'am. P by
So-
R. Sorry, P by
Yeah,
V.
so
P
for
by V.
for
Yes.
V we have taken 230. You are saying.
Yes, ma'am. Yes, ma'am.
So see, for DC supply it is 220, but here according to our supply, okay, whatever we have set up in the lab, according to that we have checked the supply voltage, and according to that we have done the calculation.
Okay, ma'am.
Okay,
Yes.
ma'am, we shouldn't show them that MI type, MC type, that video, or connection, ma'am, directly. Mona Lisa, ma'am. Mona Lisa, ma'am.
Audible?
Yeah, now it is audible, ma'am.
Okay.
Ma'am,
Actually,
actually the
the part,
terminals they have, yeah, in the, yes, ma'am.
Actually, madam shown the connection part. That's why I'm showing the connection directly. If
Well,
they
the
want, then
terminals
I'm
madam
showing.
had already explained them, ma'am. So I was thinking that
Yes,
my
yes.
type MC, that where it is used in AC and DC, that we can show them.
मैम का नेट थोड़ा स्लो चल रहा है.
ना it is being pause किए मैम ने, इसलिए वो ये हो रहा है. So ma'am, kindly play that video. That will be useful, ma'am. So student, about ammeter connection you have seen already. Then again one video was there for the voltmeter connection. I think so when you are ongoing process of the class, okay, you will know about the how to do the connection using ammeter and voltmeter. So that one you can see later on, as we have a limited time period. So it will be better to know the type of instrument that ammeter and voltmeter we use in AC also, we use in DC also. But we can't use the same instrument in AC and DC. There are some difference, and what are those difference and how to identify a AC instrument and a DC instrument, that you people should know. So that video we will play to you, and you can note down. If you have some notebook with you, you must, in every class it is advised to you that make a note, make a rough note, okay, like you present in the practice. अगर physically present होते तो एक rough note बनाते. So make a rough note and note down the every point whatever we are sharing to you, that MI type, MC type, whatever we are sharing, that you are thinking that it is important. I may be forget after the class. You will forget. May what? आप next class में आपको नहीं याद रहेगा. Whatever we teach you means it's very difficult. The one and only one thing how to remember, that make a note. अगर आपने एक note बना लिया होगा तो next class से पहले अगर if you will follow that note, so you will remind the thing whatever we taught you in the last class. So everybody, it is advised to you that make a note, and this is the video where you will know about the difference between AC and DC instrument. So it will better to make a note, okay? Yes, ma'am.
Yes, ma'am.
Ammeter is a current measuring instrument which measures the current in the circuit. Its unit is ampere and it is represented in capital A, and its symbol is I. It has very low internal resistance. That's why it is always connected in series with the circuit. According to the supply, generally ammeters are two types. One is a MI type. See, this is MI type. MI type instruments use both AC and DC. And another is MC type. MC type instruments use only DC circuit. So how to know which one is your MI type instrument and which is your MC instrument? See this symbol. See this symbol. This symbol represents in MI type instrument, and this symbol represents in MC type instrument. And another thing, how to know MI type instrument and how to know MC type instrument. In MI type instrument, initially the scale is squeezed and it is non-uniform scale. And MC type instrument is uniform scale. So see the meters. Generally, the meters have 3 terminal or 2 terminals. Always common represent the positive terminal, and rated value is either 1 ampere or 2 ampere according to the ranges. In the DC supply, common terminal represent positive and rated terminal represent negative. So according to the ranging, the scale is represented. So if we connect the 1 ampere, so you choose lower scale. If we connect 2 ampere, we choose upper scale. So according to in both types of ammeter, various ranges are there. So see, there are various range of ammeters are there. Milliammeter, 0 to 150 milliampere, 0 to 300 milliampere, 0 to 500 milliampere, 0 to 1 2 ampere, 0 to 2.5 or 5 ampere, or 0 to 5 ampere, like this.
Ma'am has told which type? MI and
MC.
Mi and MC type. Okay, Mi is moving iron type and MC type is permanent pearl moving coil type, permanent magnet moving coil type. PMMC and Mi. So Mi is used for both. Mi can be used for both AC and DC, but PMMC instrument is only used for DC. Okay, and rest symbols and all you have noted down. What was the symbol difference in the meter? Yes.
Ma'am, MC is moving coil type.
Yeah, permanent magnet moving coil type, PMMC. In short, we are saying MC. It is PMMC, permanent magnet moving coil type.
Ma'am, and MI?
Moving iron type.
Okay.
Okay. Moving iron is for AC and DC both, and moving coil type is for DC only. And another difference between AC and DC is while you will see the meter, you can guess. In MI type, you will have non-uniform scale. In the next video of voltmeter, you can check that one. In MI type, we will have non-uniform scale. It will be cramped in the starting. In the starting of the reading, you will see from 0 to 1 or 0 to 10, whatever the starting scale, it will be squeezed. Okay, उसको cramp किया जाता है in the starting MI type में. And in PMMC type, we have a uniform scale meter that you can see in the next video, that difference. And regarding the symbol also, be attentive and note down the symbol. What are the symbol explaining there? Okay. Any doubt, student?
No, ma'am.
Okay,
No,
so
ma'am.
we can proceed for that voltmeter video, then we can. Yes, ma'am. Only that, ma'am, only the starting part we can show to them, ma'am. Yeah, ma'am. Yes, ma'am. So here you can see the symbol. Okay, this is the meter. Here you can see bottom. The symbols are there. MI type. If ma'am will, yeah, this is where ma'am is putting the cursor. That is your MI type, moving iron type. Then AC symbol. Then horizontal displacement symbol means meter. See, these are all meter for the experiment. Okay. आप एक्सपेरिमेंट में ये मीटर यूज करोगे, so what will be the position of the meter, how then only the perfect reading calibration will be perfect. How it is being decided? Here one symbol is there, position of the meter, half rectangle symbol is there, you can see that one, half rectangle.
Yes, ma'am.
Is it visible down? Yeah, that half rectangle. Okay, that symbol is your position, that is horizontal position. This meter, according to the ground level, it should be put horizontally. बट समवेयर इन द पैनल बोर्ड, अगर आप अपार्टमेंट में रहते हो या कहीं पे भी आप पैनल बोर्ड में देखोगे, वर्टिकली 1 वोल्ट मीटर एंड एमीटर इज कनेक्टेड, देखे होगे. अगर अपार्टमेंट्स में होगे तो आप देखना नीचे में जहां कर आपका सप्लाई बोर्ड होगा ना, देयर यू कैन सी देयर इज अ एमीटर एंड वोल्टमीटर इज कनेक्टेड इन द पैनल बोर्ड. और या फिर स्टेबलाइजर, somebody has seen the stabilizer.
Yes, ma'am.
In
Ma'am, we
stabilizer
use
you
it
have
for
1
ACs.
voltmeter. Yes, there you can see, you can check the symbol there. वहां पे कौन सा सिंबल होगा? ये हाफ रेक्टेंगुलर सिंबल नहीं होगा. There you will have the perpendicular symbol. Perpendicular symbol, inverted T, perpendicular symbol होगा. That means that meter should be placed perpendicularly in level to the ground. Then only it will show the correct reading. Okay. So these are the symbol. So at the end, I will show you those symbol. No worry, I will show you in the like in write-up form. You can check and you can note it down. So now you proceed for the wattmeter video. It's a very important instrument, student. So whatever the thing which will be explained in this video, please make a note. Okay, it's a very important instrument. Yes, ma'am. Continue, ma'am.
Dear student, now we are going to discuss about the wattmeter. Wattmeter is a very important measuring instrument used to measure power, electrical power. So you see, this is the wattmeter. This is in watt. It is given WATTS watts. And here you see it is written cos phi. This is your power factor 0.2 and PW, that is single phase LPF. Student, wattmeter is two type, LPF and UPF. According to our load, we are using LPF is your low power factor and UPF is unit power factor. Okay, so you know, student, the formula of power is P equal to V into I, voltage into current. So voltage, it is as it is the product of V and I, voltage and current. So student, now you see this is the internal diagram of wattmeter. Here you see this is the in wattmeter, two coils are there. Current coil denoted by CC and pressure coil denoted by PC. As I am telling that it is measured voltage and current, so it has two coil, current coil and pressure coil. Okay, so current coil is like ammeter and the resistance of the current coil, it is very low of few tons. Okay, so it is thick wire, and as the pressure coil is like voltmeter and it measures the voltage, so it has many turns and the resistance of the pressure coil is very high. And student, the current coil, it is connected in series with the circuit like ammeter, and the pressure coil is connected in parallel with the circuit with voltmeter. Okay, so M and L are the two terminals in the current coil. Okay, M is denoted by, M is main, L is your load, C is common and V is voltage. Student, see, this is our wattmeter terminals. Here you see, this is our M, L. So these two terminals, these M and L are for current coil, and here you see COM, it is common, and the voltage. For voltage, three ratings are there, 150, 300 and 600. Okay, so this is MLCV. Student, apart from this, here you see other terminals of wattmeter, B1, B2 and E1, E2. Okay, so why for this terminal? Here you see, student, the voltage we know from the terminal that it is for the range 150, 300, 600. Here you see current, it is 2.5 ampere and 5 ampere. So this wattmeter is for 2.5 ampere and 5 ampere we are using. It is not written in the terminal, you see. So how we know whether it is 2.5 ampere or 5 ampere? Here you see the diagram. Students, see, when B1, B2 is connected in series, it is for low range, that is 2.5 ampere. Okay, when it is connected in parallel, it is for high range 5 ampere. Okay, so student, here you see the current setting of this 2.5 and 5 ampere. Here you see, this is M terminal, this is L terminal, 2.5 and 5, that is your B1 and B2. B1 and B2 when connected in series, you see I am connecting these two. Actually inside the wattmeter, two coils are there in current coil. Okay, so when it is in series, you see same current will flow. So this is your 2.5 ampere. 2.5 ampere when it is series B1 B2. When B1 B2 and E1 E2 is terminal. Just so now student, you see B1 B2, B1 to E2, B2 to E1 connected in parallel according to our diagram. Here when connected in parallel, the total current we are getting is 5 ampere. Okay, so this is for current setting in the wattmeter. Okay, so student, now then we are clear that in wattmeter various range of voltage and currents are there. But you see here the scale is 0 to 75. It is in watt and it is only one scale. Okay student, so when in voltmeter and ammeter multiple ranges we are using, there are two scale or upper scale, lower scale like that. But in wattmeter only you see in one scale we have to take for 3 voltage and for 2 current the reading. Okay, so we need a factor to multiply with the original reading of the wattmeter. Whatever reading may become, suppose it is 5 or 10, we cannot directly write it 5 or 10 because only one scale we are choosing. So we need a multiplying factor. You see student, the formula for multiplying factor is we have to calculate it from the voltage set and current set. That is voltage set into current set into power factor divided by full scale reading. Okay, so voltage set, suppose V set, I set, power factor by FSR. Voltage, suppose I am taking 300. Current, suppose I am taking 2.5. And the power factor, you see, already I have mentioned it is LPF type, so 0.2 it is, so it is 0.2. And the full scale reading, here it is 75. So I am writing here 75. So how much it is? 300 into 2.5 into 0.2 divided by 75, it is here 2. Okay, so this is the multiplying factor. Okay, suppose the reading coming is 5 in the wattmeter. I have to write 5 into the multiplying factor 2. The reading is my 10 watt. I cannot directly write it 5. Student, as it is directly proportional to voltage and current, you see the power factor is fixed and the full scale is fixed. If we vary the voltage and current directly proportional, then it will be increased accordingly. Okay, so this is the formula. You see in the wattmeter, this is the multiplying factor table. Okay, so multiplying factor table is, here it is voltage, we have 300, 150, 300, 600. Here it is current 2.5 and 5. Suppose I am choosing 150 and 2.5, the multiplying factor is 1. I will increase the voltage to 300. You see, voltage to 300, the multiplying factor is 2. Then 600, 2.5, it is 4. Okay, so if I am increasing the current, it is 5. Then 150 and 5 ampere, it is 2. 300, 5 ampere, it is 4. 600, 5 ampere, it is 8. If we tally this table with our formula, then we are getting these readings. Okay, so student, this is all about the wattmeter and wattmeter reading how we will take. So this you have made, it is helpful to calculation of power also. In different experiment we are using wattmeter. So thank you.
Any doubts, student?
Excuse me, ma'am.
Yes.
Ma'am, ma'am has multiplied 5 into 2 is equal to 10 watt. Ma'am, where that 5 came from? Can you?
There's multiplying factor, na, the formula. Have you noted down the formula?
Yes, ma'am. Yes, ma'am.
Vi cos phi divided by
Full scale.
full scale reading. So So where it has been, आपको जहाँ that's why I was telling where you will have
V1
doubt at that
in
point.
the wattmeter.
So 5 is the current here, 5 ampere. We have two option here, current 2.5 and 5 ampere. So how to know according to the settings of the wattmeter, we can say that this instrument setting is at 2.5 or 5. Okay, ये setting जो है ना, यहाँ पे ये physically diagram में बताया जा रहा है. तो 4 terminals है ना, your B1, B2, E1, E2. Okay, तो वो उसको अगर series में है, then we will take the lower value of current 2.5. If it is in parallel, we will take higher values. See this 4 terminal B1, B2, E1, E2. So अभी ये parallel है. See this one. This is parallel now. So that's why your current ma'am has taken 5 ampere, not 2.5. If it has been connected in series, अगर एक साथ connect होता, तो आपका लेते हैं उसको 2.5 ampere.
Okay,
So
got
current
it.
settings vary from meter to meter. Okay, आपका मीटर में आप जैसे सेटिंग्स होगा, like you want wattmeter, this wattmeter for 2.5 ampere, or you can say you want for 1 ampere. Okay, तो 1 ampere के लिए आप कौन सा सेटिंग करोगे? 2.5 वाला सेटिंग करोगे, like you will do it series. 5
Yes,
ampere का सेटिंग तो नहीं करोगे, unnecessary loss होगा. So you will set it for 2.5. अगर आपका रीडिंग है, आपका your experimental current value is 3 ampere, then you will set it for 5 ampere setting. Okay, so that varies according to your experiment. Okay, so VSET was VSET. आप जो VSET use करोगे, that is your VSET. Means आपका उसमें भी option है like 300, 600 watt, 150, whatever terminals में दिखाया जाएगा, like 150, 300, 600. Out of these 3 settings, what is your requirement? If you need for 250 volt, you will take 300 terminal. If you need for 75 volt, you will take 150 terminal. माने उससे ज्यादा वाला टर्मिनल को ही लोगे, नियरर एंड ग्रेटर. For 250 volt, you can't take 150 volt terminal. Is it clear? So V set आपको मिल गया according to whatever you have set. I set आपको मिल गया. Then power factor उस wattmeter में लिखा हुआ होगा, that is 0.2 divided by full scale reading, तो पता ही होगा scale देखे. Now it is clear?
Yes, ma'am. Yes, ma'am.
Everybody, Neha, have you noted down?
Yes, ma'am.
Achal?
Yes, ma'am.
Okay. Everybody should be attentive and should note down all the things. Okay. So after 2 to 3 experiments, starting 4 number of experiment will be over, then wattmeter will be introduced to you, not in the initially. Okay. So it is quite difficult to remember at the 5th number of classes or 5th number of experiment that what was the wattmeter. So that's why I told you to make a note. So if it is no doubt in this wattmeter section, then we can proceed for the variac one. Okay then? Okay, ma'am, we can go for the variac.
Now we have to check how to connect a single phase variac to the circuit. So first of all, we have to know about something, the single phase variac. What is the single phase variac? The single phase variac. It's a single winding transformer, and it's also known as your auto transformer, and its other commercial name also there, that is your dimmer start, and its principle of operation depends upon your self inductance method, and it has a single winding having wounded on the limb, and here it is also your voltage required to the circuit is and voltage regulated by AC circuit. Here we have to connect the single phase variac to a voltmeter having range 0 to 300 volt and a lamp load. That lamp is made of tungsten and having the lamp's specification is 200 watt to 30 volt, and here the voltmeter range is 0 to 300 volt AC, and this single phase variac, it is connected to the circuit. Its specification is also single phase to 70 volt and 15 ampere. Now, according to the circuit diagram, we have to connect the circuit, right? Now that means one of the terminal of a variac connected here. The voltmeter range is showing here a common terminal, and 300 volt. It is, that means we have to make this voltmeter measure in between common and 300 volt. That means it's upper scale. It is your upper scale, right? And so first of all we have to connect the variac. Now your first terminal of a variac connected to the common point of the voltmeter, and from common point it is this terminal connected to the lamp load, that is the lamp load's one terminal. So according to the circuit diagram, first of all variac connected to a voltmeter's first terminal, that is common, and from that variac it will be also connected to lamp load. So it is connected first, then lamp load's next terminal, that means this lamp load's next terminal, this terminal connected to voltmeter's other terminal and variac's other terminal, that means this point. So now supply, we have to give the supply, right? Now I am switch on the circuit. Now I have to switch on, and the lamp is glowing here, indicator is glowing. Now I am increasing this variac. Suppose I am increased till 50. That means here that value is showing 50. That is exact value because we are connecting the terminal in between common and 300 volt. That's why we are taking the value of upper scale. That means the value showing here, this is for your lower scale, that is 0 to 150, but it is for upper scale just double. That means 50 in place of 50, we have to take 100 volt. That means in 100 volt supply given, lamp will be glowing in this much. And if I am just increases, that means if I am increases to 70, that means it is 140 volt, lamp glowing slightly higher than previous one. And if I am just increases up to 100, that means it's I am giving 200 volt, then 200 volt, that means lamp glowing much more higher than previous one. Okay.
So student got some knowledge about the variac. Forgot about the connection that you will also consider in the during the experiment. But the main thing that what is variac, what is its function, and that you know. So what is its function generally for the variac?
To step up voltage or down voltage.
Yeah, it can step up and it can also step down. Both the thing. How see as the sir is increasing, it is going from 0. Now you also see the scale from 0 to 250. Okay, the scale is there. So you keep on increasing by varying this regulator point. You keep on increasing, and after getting the full supply voltage, then also you get a decrease. Up increase से decrease भी तो कर रहे हो ना? Again for coming to the 0. Yes.
बट मैम ने बोला था कि मतलब ये सिर्फ स्टेप डाउन ट्रांसफर स्टेप डाउन
Yeah, actually because step down like means हम लोग रिकॉर्डिंग means ये टैपिंग टाइप है. स्टेप अप एंड स्टेप डाउन ट्रांसफॉर्मर जो होता है that is different one transformer can be used for step up also, for step down also. तो two windings वहाँ पे होते हैं, different primary and secondary winding. That's why मैम had explained क्यों आपको confusion ना हो कि यहाँ पर two windings नहीं है. But here both the function
वेरिएक स्टेप डाउन के लिए होता है,
स्टेप डाउन के लिए नहीं, स्टेप अप के लिए बोला होगा ना. मिनिमम से मैक्सिमम जा रहा है ना.
मैम 0 वोल्ट से 230 वोल्ट तक के बीच में बोली है मैम कि आप अप और डाउन दोनों कर सकते हैं वोल्ट.
हाँ, वेरी कर सकते हो. आप सप्लाई कितना दे रहे हो? 230. आप 230 से ज्यादा तो ही ना मिल सकता है. लाइक यू कांट गेट 400 हियर. That is the thing. You can't get the maximum supply voltage आपका 230 रहेगा. Max to max you can get 240 volt, but you can't get 300, 350 volt using this variac. So this is one type of transformer that varies from minimum to maximum, whatever the supply voltage providing to you. So also it has a winding inside that that is your one winding. The difference between the other transformer and this single phase auto transformer, it is also known as auto transformer. The difference क्या है, उसमें two windings होता है, primary and secondary. Here we have only one winding, and using that one winding we can vary the voltage from minimum to maximum, the AC voltage, not for DC. This is used for AC voltage from minimum to maximum. Okay. So the specific is that it has one winding and also it is known as single phase auto transformer. It is clear?
Yes.
Okay. So you can't step up, you can't say that step up, step down function. Obviously, if you will consider from 0 and it is taking to 230, तो वो step up कर रहा है, but उतना ही करेगा जितना supply voltage उसको max to max दिया जाएगा. Input supply voltage से ज़्यादा वो नहीं करे, ठीक है? So okay, so variac is clear. Ma'am, which video we can play next? In same like variac, we use in DC. We use yes, ma'am. Ma'am,
Madam, can I share the rheostat video? Or
yeah, ma'am. Multimeter we can share.
Because it is already 57.
But at least rheostat video, they should know that in DC what we use for the variation.
Okay. I'm sharing.
Yes, ma'am. So another video, that is rheostat connection. Forget about the connection now. What are the terminals and how it is being varied. So DC में हम जब voltage variation के लिए use करते हैं, that is potential divider or also known as rheostat. This you have been used before in your 12th, I think so. So go through this video, then you can ask if you have any doubt.
Dear students, today we will discuss about the potential divider arrangement. Here in that arrangement, this is your DC supply, means 220 volt, and this is positive and this is negative, and this is your potential divider or rheostat circuit diagram, and this rating is 300 ohm and 1.7 ampere, and in that circuit connection this point is minimum position and this point is maximum position. In minimum position this is 0 volt and maximum position this is 220 volt. For that connection only this is 0 and this is maximum. As per our circuit diagram, this one is your fixed point and this one is your fixed point and this one is your variable point. According to circuit diagram, now we will connect the circuit. And this one is your 1.7 ampere 300 ohm rating rheostat, and in that rheostat this point is my fixed point. This is one fixed point and this one is your another fixed point, and this one is your variable point, and this fixed point goes to one positive and this fixed point goes to negative, and this one is your my variable point. According to that, this variable point goes to voltmeter common point. This is the variable point, this goes to the common plus point of the voltmeter, and from that voltmeter goes to bulb, from that point goes to bulb, and other end of the bulb goes to the voltmeter 300. Other end of the bulb goes to the voltmeter 300 point, and from that 300 point goes to the fixed point of the rheostat, and same as to my circuit connection, this 300 goes to the fixed end of the rheostat. According to that, This is my minimum position and this is my maximum position. Now we will connect the circuit. And on it. Then we will vary the slowly. Then voltage will slowly increasing and bulb will glowing. Bulb is glowing and then voltmeter also slowly increasing. Then also bulb also
Goes brighter.
and brighter. Now it is maximum. Okay, means maximum voltage is my 1.
So, madam, am I audible? Hello?
Yes, ma'am. Yes, ma'am.
Okay. So, all of you understand about the rheostat or potential divider connection and how it works and in which supply it will work. Yes.
Yes, ma'am.
Yes, ma'am.
Okay. So, if any doubt, just ask. Otherwise, I will stop my screen sharing. Okay. Madam, I think there is no doubt.
Yes, ma'am. Yes, ma'am. You can stop. So rheostat, you have understand everybody, student? Same thing.
Yes,
Like
ma'am.
there we are using AC. We are using. There was a coil. Coil turns to means inductor. Here we use the means rheostat is also known as the potential divider. This one you have must have been used in the 12th also. देखिए हो ना?
Yes,
Some
ma'am.
of you.
Yes,
Yes.
ma'am.
Yeah, in physics
Excuse me,
lab.
ma'am.
Yes.
Ma'am, we have, ma'am, in rheostat, we can apply AC voltmeter also.
AC voltage? No.
Yes, ma'am. Ma'am, only DC it will.
Only
work.
DC. Yeah.
Okay, ma'am.
For AC we can use variac, and also in DC not only rheostat, we have another instrument also for DC. When in the next class we will start the experiment. You can see like we have another instrument for the DC voltage regulation, but rheostat or potential divider you can say that it is used for varying the DC voltage. Okay.
Okay, ma'am.
Okay. Yes. Anybody else having any doubt?
No, ma'am.
So that
No, ma'am, no,
also time is over. So in the next class we can start the experiment as per ma'am. Ma'am will explain the theory, then we can go for the simulation and video, then simulation. Okay.
Yes, ma'am.
Yes,
Okay.
Yes,
Okay,
ma'am.
ma'am.
Okay,
Ma'am,
okay
what
then.
about the attendance? Ma'am,
Yes,
what
ma'am. What
about
about the attendance, ma'am?
Ma'am had already taken na in the
No,
mid
ma'am.
also ma'am.
Not everyone.
No, ma'am, everyone.
Not everyone.
Ma'am, where?
Okay, so one thing we can do.
Excuse me, ma'am.
Yeah.
Ma'am, at the time of attendance, my network, I have a network issue, ma'am.
Yeah, I understand. One thing you people can do, those who have not responded at the time of attendance, they can write up in the chat box. Okay.
Ma'am,
Write down in the chat.
Ma'am,
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 didn't
it's not
ask
about the
our roll number.
responding. Ma'am,
Yeah, I
yes,
understand. Ma'am hadn't called you. I
Yes,
have
ma'am.
listened
That
that.
was a
Ma'am-
random attendance.
Yeah, random attendance ma'am had taken at that time. So those who have not responded mean those who have not given their attendance
Yes, ma'am.
at that time. Now they